but the entire Baltic Sea, creating towering waves which ran up to 20.5 meters or 67.3 feet above sea level. Not only do we know that this event occurred, but we have some form of historical record of the event as well. As, at 28.5 meters above sea level, the exact same maximum run-up height above the modern sea level the tsunami appeared to have produced as a carving in stone of a boat with 7 passengers, one attempting to climb back on board. Although correlation does not equal causation, this carving could represent a mural to a spectacular Bronze Age story of survival from an ancient tsunami, marking where the eventual ship became stranded. What makes this ancient tsunami all the more fascinating is the link several recent scientific papers have attempted to make between it and a large meteorite impact which occurred around the same time. After all, the tsunami is best dated to within 11 years of 1171 BCE, while the cluster of 9 Kali craters within Estonia all formed in a single event sometime between 1650 BCE and 750 BCE. So, are the 2 most significant geologic events to occur in the region of the Baltic Sea during the local Bronze Age linked? First, let's look at the Kali impact event. Kali impact event. I want to first note that the age of this feature is still widely debated, and our most recent high-quality carbon dates suggest it formed between 1530 BCE and 1450 BCE. However, other papers suggest around 1187 BCE, which essentially fits the date of our 1171 BCE tsunami figure. The 9 Kali craters formed when a dense iron-nickel meteorite which measured 6.3 meters or 20.6 feet wide and weighed 2,700 metric tons impacted Earth. Due to the asteroid's small size, 1/3 of its mass broke into 8 large fragments during its atmospheric entry, while the main mass of material continued. Less than a second later, these fragments struck a densely forested area of Estonia, generating a series of massive explosions at locations up to 1,100 meters distant from one another. Altogether, these explosions produced at maximum the equivalent of a 20 kiloton explosion of TNT. There is currently no evidence that any of these fragments impacted the Baltic Sea, even if we consider that the land was 14 meters lower at the time due to isostatic rebound still being ongoing. And, even if the entire meteorite stayed as one piece and impacted the Baltic Sea, the depth of water would not have mattered, as it at worst would have only generated a maximum 16 centimeter high tsunami at 250 kilometers distant. However, there is another possibility. Generally speaking, magnitude 4 to 5.9 earthquakes can create landslides on already unstable slopes, while magnitude 6 or higher quakes can generate widespread landslides not just on previously unstable slopes. Asteroid impacts can generate earthquakes, so if we assume that an unusually high amount of the impact's energy transferred into the ground, it could have technically induced a magnitude 4.1 earthquake. This is only negligibly higher than the general average minimum earthquake required to generate a slope failure, but this can only occur on an already unstable slope. Yet, no major appropriately aged submarine or onshore landslide deposits are known, and we would be looking for something on the order of 0.2 to 5 cubic kilometers in volume. Glacial rebound. Yet, there is something far more likely, involving a hazard which seemingly no longer exists in Sweden. During the last glacial maximum, much of Sweden was covered in up to 3,000 meters thick of ice, which compressed the crust downwards due to its mass. Once this melted, the land rebounded upwards, with this process still ongoing today. Speculation. This process occurred unevenly, leading to several magnitude 7 and 8 earthquakes due to large ruptures this uneven process created. I am thus hypothesizing that one such event around a magnitude 7 struck the region around 1171 BCE, either uplifting enough water to create a tsunami or generating a large enough landslide to generate a regional tsunami.